Hello everyone, this is Bradley. So today this is a tutorial of this laser engraving animation I've done quite a long time ago. Many people were asking for tutorials. Here just to mention that the similar kind of techniques are being mentioned over and over again since last November. And at some point, I suppose you should be able to get some sort of idea to get it work if you have watched this channel for quite long. And that's basically my expectation, because by the end of the day, it's your responsibility of problem solving. So you have to use the knowledge you have learned somewhere to accomplish certain jobs. So today, let's start. So here in Blender, as always, I'm going to use the presets which you can download for free from the link in the description. We firstly need to start with a text, and the routine method is to use a string to curve nodes, which is very handy. And you can just type whatever you want. Here I'm just going to type geo and take a center and middle. Okay, and you can use whatever font you want, but here I'm just going to use the default. Another thing we need is actually to have a grid, so we can join geometry to see both our text and the grid. Okay. And let's enlarge this grid. There's one issue that you need to realize is that our grid needs to be divided as much as possible so that we can deform it later. And we can here, let's just adjust a little bit to the text so that we do not need extra subdivision, which slows down our computer. Just roughly should be enough for the moment. Okay, and then next thing is we're going to do a kind of fold to depress certain areas. So basically, we need to use proximity fold. Okay, but there is one issue that you need to realize, that while we're outputting the curves, I need a mesh. The reason, as I've explained in the tutorial, is that this proximity fold is based on the geometry proximity. And if you just use the geometry proximity, so let's take a realize instance and plug the geometry into the target. We evaluate the points, and then let's take a set position. And then we also need to convert the purple, the gray into purple, which by using a combine XYZ and plug that to the offset, it will give you a warning. It says the input geometry has unsupported type, which is curve. Okay. It means the curve is not being supported. So this is a current limitation within geometrynodes. I definitely think it will be resolved. But for the moment, you need to know that since our proximity fold is using geometry proximity, then we are going to have exactly the same issue with this proximity fold. As here you can see, we do not have a plane at all. On the one side, we have done mistakes with this position and offset. So plug into the offset instead of the position. And you see there is no effect on either of them, okay, because of unsupported type. So we need to convert the curve to mesh, which is very simple, and you convert that, still not working. The reason is that you have to enable the mesh mode, so untick this box, and also you need to increase the scale offset so that it determines how much of the distance from the points are being affected. So now goes back to the solid view. It's not very clear to see, but let's take a remap 0 to 1, which is basically a map range. The only difference is instead of 5 sockets, I only have 3 sockets, because I know I'm remapping 0 to 1. Okay, and by manipulating this minimum and maximum, you can see how it goes. The evaluation only converts the point to points without considering all these kind of edges. So the best way we do is to use a resample curve and turn that to the length, so that we have a kind of uniform scale for us to have curve into points. Okay, so this is good enough. And you can manipulate this minimum and maximum to determine whether it's actually bulging or it's depressing. I think I will go for the depressing. Here, you may want to ask that, why don't I just use the minimum and maximum settings, which can basically do the same thing within proximity fold? The reason is, one, it's possible that I want to use this fold value to other places. So it will be better if I keep consistent 0 to 1. Another reason is, for example, in this particular case, I would like to use a float curve, which is basically clipping at 0 to 1. So we are trying to do a kind of remap. For example, I'm going to turn on this a little bit. and I'm going to turn this point down. So finally you can see there's kind of edge which is being elevated, which is determined by our depression at this point. And you can definitely manipulate this minimum and the maximum to effect. If you directly manipulate the minimum and the maximum at the proximity fourth, then this entire float curve will give rather wrong results because it's supposed to work in the range of 0 to 1. So for example, let's just try with this kind of value. You will see a lot of problems. You can try in your free time, but I'm telling you the reason. Okay. So this is it. Another thing that we may potentially would like to do is everything now is very uniform. So we can try to add some noise 3D, which is basically a noise texture node. And you can add that within the Z or without Z. So for example, let's just take a vector mass. So we are trying to add a more general noise 3D node onto it, and it looks like this. So we can increase the frequency and so on, and decrease the scale definitely. Another thing is that I would like to restrict this noise into the area which is associated with this elevation or depression. So in this case, we just take another vector mass and take that into a scale and use our fourth so that it only affecting the area affected by the fourth at the same time. So as you can see, this is kind of masking. Okay, and you can try to depress or whatever, increasing the scale, decrease the scale. So you get a kind of idea. You can definitely polish more, but we're going to move on to further about animating this kind of depressing. In many of my tutorials about the splines, I've discussed to animate this kind of spline, you either use the index or you use the spline parameter. Actually, almost 99% of time I was using spline parameter because it's very straightforward. Because from start to the end, you get 0 to 1, which is very handy. Everything is being remapped properly, not like the index you have to remap by yourself. Okay, there are lots of various problems, but there is a issue. You also need to realize that here we are working with a grid. So we are trying to deform the grid instead of animating the spline. Okay, which means whatever we're getting from splines, we need to transfer attributes so that we can work with a grid. So this is one issue. So let's go back to our curves. Okay, and combining all this kind of fourth, we definitely need a mass node for multiplication. So multiply, and we need another multiply. Okay, every time we just keep multiply the fourth that we generated. And as being mentioned, this fourth can be either generated from the index or spline parameter. In my recent trail deformation tutorial, I've discussed the similar kind of concepts. If you directly plug this resample curve and the spline parameter into the attribute, and here let's transfer attribute, and it will give you the warning sign and it will tell you that the source geometry must contain a mesh. It means it does not support the curve for the moment which you have the curve to mesh. And even if you curve to mesh, it does not really work because we also need to take that to the nearest. And it still does not work because once you curve to mesh, there's definitely no spline. So you have to capture attribute beforehand. Okay. So these are very important parts. And it's kind of very tedious, but you have to deal with that. However, even if after you're doing all these kind of steps, there are still problems because transfer attributes never respect with the proximity. What does it mean? It means that when there are some blank area which has to be transferred with an attribute, but the original mesh is too far away, so they get some whatever stuff according to the proximity. So basically all vertices will be affected with these transfer attributes. So here we would like to limit this transfer attribute result to only a certain area close to the spline instead of this kind of far area. That's why I've made a transfer attribute in proximity to do this kind of function. The way I do this is very simple. If you do not have this preset, then you just have to do another proximity fourth to multiply with this whatever. Okay. So here, instead of using the transfer attribute, I'm just going to use the transfer attribute in proximity. And I need the source, I need an attribute, output the attribute. You can see that this does not really help anything unless you try to minimize the size. Okay, as you can see. So now we should have some effect. It's not very obvious with the animation, but to animate this spline parameter, you just use a mask node. Okay, and now you can actually see some sort of interesting thing which is happening. By plus minus these values, you can actually see there is a growth of this grooving effect. And we can definitely clamp that so that you can see without overshooting to other areas. It looks definitely great. Okay. And this is the effect that we're looking for. You get a kind of growth. Okay. Also to know that this part of a spline parameter Falloff can also be used for our color changes eventually. So to output the color changes, we definitely need to capture the attribute because we finally need to preserve all this kind of source position being used within transfer attribute. Otherwise, it will just be deformed and everything will be changed, as I've explained in nuclear explosion tutorial. So we output these attributes. Let's name that as a C. And we definitely need a material for our grid. So let's add a material. So within the material, so it goes to the shader. I'm just going to take an attribute C. If I goes to the base color and it goes to material preview, and you can see that it's kind of a clear black and white, and you can animate it and see the result. Okay. There is definitely one problem that you will see, that now we have this kind of animation of growth. What if I would like to cancel this white part? It's actually very simple, that you just duplicate everything. So we're going to start to duplicate this process. So we definitely need a capture so that we can output something. We also need to transfer. So let's Control-Shift-D so that you can duplicate it with linkage. But you are not going to use the same linkage completely. We're going to add the spline parameter mask node and using the new capture for that. Okay, so let's put the attribute into and finally output that. Okay, so this is basically completed. And let's go to panels. Let's just name it as a D. And we can take a attribute D. So right now, instead of using the base color, I'm going to use the emission shader. Okay, and take the base color into black so that I can see the white parts as we seen earlier. So here, let's take a mask node to subtract these two Falloff. And take the color in. Technically speaking, you should use the factor, but it does not really matter in this case, because we're outputting black and white anyway. And right now everything is black. This is because these two Falloff are completely identical, so they are canceling each other. So here I'm going to take a mask node and take a value node so that I can control two values at the same time. Okay, so one plug to that, the other plugs to that. But I'm going to take a subtraction. So that I'm going to take a kind of interval, a difference between these two values. So right now it may not be very obvious, but as you can see, so there was a white part that has been created and then it disappears. So this is the entire point. Okay. Here you might wonder, why don't I just do all this kind of subtraction math within geometry nodes? Because outputting two different attributes sometimes is a little bit performance intensive in my opinion. The reason I'm doing this because I would like to preserve this C output so that I can plug that into the base color for a kind of light. And then we are going to add some colors with mixed RGB. Mixed RGB is also a very calculation intensive node, but I like it, so whatever. Okay, so here is what I'm going to do. I'm going to add a kind of orange color. This is just an example. It does not necessarily follow exactly. You can do whatever you want, and I'm going to turn this to black. Okay, and another is still the orange. Why they are the same color? And I'm going to turn on this emission shaders to be with the blue. Yes. And you can turn on the strength, intensity, and so on and so forth. So now it looks kind of nice, and we try to play with this animation. And initially, so we have this kind of base color, and then there is a light. There is one issue that I realized is we should not really clamp this subtraction, so that you can see there is a light, which is this is too intensive. Okay, and then you can see the disappearance of that. Okay. So you see this kind of animation, and you can definitely tweak more with it by using the color ramp, so that you can make the kind of transition sharper between these two borders. Otherwise, they're having the same color. So now this looks like this. Okay, and then there is a subtraction. So you can decrease or increase. I think I'm going to decrease it. Basically, just try to play around with all these kind of parameters, then it should be fine. Okay. Next, we're going to forget about the materials. Oh, finally we finished something. Okay, and then we are going to focus on the laser beam, because you have to have some triggers so that make your animation more reasonable. Okay. So talking about the laser beam, which is basically we need instance curves. So let's start with the curve linear. Or you can start with a curve line, it's okay. So let's start with curve line. Okay, using curve line instead of curve linear. And then I'm going to instance that. So let's instance at a point instance. Okay. So this is the instances, and then we need to define the points. So the points must be from splines, so let's just follow splines. Okay, I'm going to use the curves after capturing so that we can potentially use these parameters later. Although I don't think there will be a chance to use them, but we will see. Okay, so now we have these endpoints, and we'll just instance that. It's not very clear to see because we haven't output anything from this yet. So we output that and disable our text. Yes, so this is how it looks like. And I'm going to take a realized instance so that we can access all these kind of vertices and take a set point, set position. And I'm only going to affect the endpoints. So let's take a, what's that called? The endpoint selection. Plug the selection into the selection, and I'm only going to affect the end sides, which is at 1. Okay. And I'm going to define a specific point. Let's just combine XYZ. And you can just move that within the viewport. I hate all these kind of parameter things, but I think this is fine. Usually I would just take an object info and use the location from our empties also, so that we can just manipulate more easily within the viewport instead of just trying to dealing with these numbers, which I have no idea what are they about. But I think in this case it will just be fine. Okay. And the good part with all this kind of curve splines is by manipulating the parameters that the points will just flow so that our curve will also be instanced differently. But in this case, it does not work at all because we need to have a reset spline cyclic. The whole point is I've explained tons of times actually, so that you have a trim curve inside to do the work. But our trim curve currently does not work for spline for cyclic spline, so you have to make them non-cyclic, so that you can use the parameters to control that. Okay, which is good. And there is one issue that you realized previously when we looking at our materials. So let's take these values into, and you can see that let's start with -1. Okay, so right now we have nothing. Let's also point instance to make these kind of curves, bevel curve with a kind of volume, decrease the radius. Okay, so let's take a look with how they are dealing with themselves, and you can see this. So not only they are not synchronized themselves, but the most major problem I'm realizing is that they're going at a different direction. Okay, so one is positive, one is negative. So we have to take a negative. So that I'm using a negative value. So a positive value or negative value for this parameter stuff. Okay, so that's now they are following each other, which is very good. Yes, this is awesome. Next, we are going to make this laser beam to disappear. Or we are actually going to animate the appearing and the disappearing, because you cannot just make this laser beam hanging here. To make it appear or disappear, we basically use the set radius node, set curve radius, so that when the radius is 0, then there's no curves you can see, but when radius is 1, you can see its curve, and controlled by secondary radius. Okay, so how to do this? Oh, but it's basically depending on the parameters that we set for our curves. So this is the value that we are controlling. And I don't know, so we have to do a map range. Okay. Because knowing that our animation started from the -1 and finally goes to the +1. That's our animation. Or actually positive 1.4, because there is another canceling being done here. Okay, but I'm not going to worry too much about that for now. So let's just take that to 1.4, -1, so that we remap that to 0 to 1, so that we can have a float curve. And we're going to remap, probably not remap, because 0 to 1 should be fine. Okay, so how are we going to control this exactly? This is a very good question. I don't know. So I'm going to take the... You basically just control this and make it disappear. I think when it reaches 0, it should disappear. Yes, something like that. You get a kind of idea, then it will just be fine. So after it reaches destination, then it's slowly disappearing itself. So this is just kind of idea. Let's just take that to 1.2. And by manipulating these parameters, yes, then it's fine. So initially we have no laser beam, but the laser beam starts to appear slowly. Okay, so we take it -0.2. So initially no laser beam. So now we have laser beam and we have this animation and depressions. And then we have this animation and the laser beam start to fade out. This is kind of idea. Okay. And I think we finished the laser beam. In reality, definitely there are more stuff that you need to tweak, because I also realized that our depression is not really following well with our material or the laser beam, but I think that's kind of a minor thing you can tweak by your own. I'm not going to cover that. Next, we're going to deal with the particles. Dealing with the particles is pretty straightforward. I've discussed a similar kind of concept within my hair tutorial. So it's basically the same as you instance the hair, that you need to bevel curve, so that you create a kind of a volume for you to instance something. Okay, so this is what we're getting right now. And let's decrease the radius. I don't know, I don't need it to be kind of large or anything. Just the kind of a tiny line is important. Is good enough, because my whole point is to distribute particles onto that, so that I can instance these particles. Okay, and just about 10,000 should be fine, or 1,000. And then we're just we can set a position to animate that, but I realize we are going to animate that on normal, so that's just a normal displacement. Okay, so this is also a reason that why we need a mesh, so that we do not only get the points, but we also get its normals. Okay, and because the points by itself does not contain any normal, so normal displacement does not work directly unless you plug the normal. And this is our animation. Actually not. This is the setup. The animation essentially is triggered by several things. So of course it should follow the laser beam, which means we need a transfer attribute. Why we need a transfer attribute? Because we're not working on splines, we're working on the points generated on splines. Okay, so we need a transfer attribute. And we can just use the old transfer that we have done. And of course I need to remap 0 to 1 so that I can dealing with the magnitudes it has been created. Okay. So this is one part. We're going to deal with this value later, but I want to tell you the trigger. As I mentioned, as always, that the entire animation triggering actually is done by these values. So now we can actually see how this animation is being done. That from negative 1.2, we start to have the laser beam, and the laser beam start to move, and it starts to trigger all these kind of particles and the depressions, and finally this is done. Yes, and this is done. Okay, very straightforward. And this animation is done. Definitely you can see there are some flaws, but it's kind of very easy that if you take normal and compare. I guess I'm going to compare with the less than. Actually, I need to separate x, y, z. So that's when the z is negative, then there's no instances. I need to take a float. Okay, so I'm going to use the greater than. And then everything is shooting up. Definitely there are more things that you can potentially play around. For example, you can dealing with this normal. Right now you can see this kind of patterns of normal distribution. So we're going to add some vector maths, just to add some random vector. So you can use a random value. It's completely okay. No, it's not okay. We're going to take a negative. So that's a negative value and a positive value. And just a little bit, it doesn't work. The reason, I don't know. What's the reason it does not really work? Oh, because the negative and the maximum is the same. Yes. And then you increase the values, then you can see that everything is being randomized more. So these are just the examples, and if you do not like this large degree, then you can just decrease the maximum a little bit. If you ever want to have different magnitude, you can also take a random value, so take a randomness, so that every point can get a different values, and take 0.33. These are just the examples. You can try to manipulate by your own about how to dealing with all this kind of stuff. And in order to make them showing up in render, you definitely need a point instance. Unfortunately, right now, render engine does not recognize these points, so you have to do this step. I'm just going to use a cylinder. And I'm going to take the scale to be extremely low. And here we are going to align them, align with to vector, which is their normal, so that we can take the rotations. So they are following their directions. Okay. And there's also one kind of issue that you need to realize, that after these particles finish in the animation, they should disappear. And we're going to deal with this disappear with our scale. And we're still going to use the parameter. So we started with the float range, a float curve. Okay. And we're going to make it 0, 0 at the beginning and at the end. And we can plug this remap 0 to 1 to it. 0.02. Right now we have all these kind of particles disappeared, but as soon as we try to animate these values, you should be able to see how they are actually going. So we start to have the laser beam start to go, and we have particles, and they appear and disappear, and so on and so forth. And we basically have finished this animation. So basically that's it. In reality, this node tree is more complicated because there are lots of parameters and additional settings that you need to do. For example, in order to have different text, to have a different time of animation, I had a delay for, but I do not want to cover that in this tutorial. I think it's already too long. Okay, but basically that's it. You can tweak all these kind of settings, make the particles larger and smaller. And yeah, basically this is it. Or color ramp all this kind of fourth to make them sharper, because I realized this depression is not very obvious at this stage. But these are just additional things that you might be concerned with, but I probably will just stop my tutorial here. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.